Okay, thank you. Yeah, so thanks everybody for joining us today. We have a great session ahead of us on interaction and animation. We have a good set of short papers and speakers today. So each talk is going to be a pre-recorded video that's around 7 or 8 minutes long, and then we'll have 2 or 3 minutes for live Q&A afterward. So if you have questions, then please post them either on the comments on YouTube or to the Discord channel, and I'll read them out for our speakers. Yeah, so let's go ahead and get started. Our first paper is going to be presented by Yifan. on the topic facilitating exploration with interaction snapshots under high latency.
Folks, I'm Yifan, and I'm a PhD student at UC Berkeley. Today I'll be talking to you about interaction snapshots, work done with Professors Remco, Zhou, and Eugene. When interacting with visualizations that talk to a large database, invariably some remote compute is involved, and that means latency from the computation and the networking. Latency is frustrating. Liu and Hare found that even a 500 millisecond latency decreases user activity and dataset coverage. To solve this issue, one solution is to reduce latency with a better backend. And there are many techniques ranging from using GPUs, lineage, prefetching, and some solutions have looked beyond the backend to the front end, and this includes techniques like progressive and optimistic visualizations. We took inspiration from the latter two techniques, which combine both the backend and the front end, and ask the question if we can design something that uses just the front end solutions to create a latency resilient user experience. Not requiring latency to be removed might be appealing to practitioners who do not want to migrate their data or limit their users to those with high bandwidths. Of course, front-end solutions have their own risks. It requires users to adapt to a different UX, which may not be as effective as if there were no latency. This different set of design trade-offs is still worth exploring given the challenges to back-end migrations and the severe negative impact of latency. To develop new designs, we first introspect on the missing opportunities with two common interaction designs to deal with latency. One is blocking. So on the diagram to the bottom, the top timeline shows the request triggered by interactions, and the bottom timeline shows response that then renders the results. The red X on the request timeline represents the interactions that have been ignored by the system since the previous interaction request has not yet gotten a response. Another design is non-blocking, arguably a better design where users are allowed to make new interactions, but the stale requests are canceled, marked by the red crosses across the response timeline. So as we can see, only the most recent one is shown. In fact, in both of these cases, only one interaction is allowed at a time. And so this brings us to ask the question, what if we allow the users to concurrently interact and let the past result render asynchronously? This way, the results are concurrently processed and the overall wait time is amortized. However, latency could vary and it quickly could get difficult to make sense of what is happening. The results might change too quickly, and worse still, sometimes the results does not even correspond to the most recent interactions, as shown here. The results for the selection, lime, is actually shown now for the selection result of mango, and this happened because the results of lime took a little longer to process. So these problematic experiences arise from the core issue that asynchrony violates direct manipulation, where the object of interest should be immediately visible. So clearly, a special design is needed to support asynchrony. Our insight is to use past interactions, i.e. history, to serve as a stabilizing visual anchor. As shown in this example, as the user interacts, asynchronous interactions are appended to what we call interaction snapshots. Creating snapshots takes 3 steps. First is to keep track of prior interactions, and the second is to show the interaction results, and the third is creating a temporal ordering of these results. So to test our hypothesis, we ran the study with 47 participants on Amazon Mechanical Turk and asked them questions to use a pilot interface we illustrated earlier to complete a simple task. We found that using the snapshots design, the participants were much faster. So one of the participants said that the ability to load several months at once definitely offset any latency. In contrast, when using the other designs, participants have described the tasks as painful, awful, and frustrating. So now the natural question is, how do snapshots work for more complex visualizations beyond these simple charts? And so like this dashboard we see here of wildfires in the United States, it's pretty complex and it takes up a larger portion of the screen. And the answer is to simply apply the same 3 steps. So as shown in this example here, we first capture the user's past interactions, and then we show the results of the interaction in a smaller snapshot and in an order that meets the user's expectation. We ran a study with 6 Berkeley data science majors via Zoom and had them use a similar dashboard interface. So unlike the previous task-based Mechanical Turk pilot, we asked the users to explore the dataset for about 7 minutes and then summarize their findings at the end. To understand the results, consider the visualization of their action traces, with time going from left to right on the x-axis and the participants on the y-axis. We tracked their interactions with the visualizations and noted the ones that were concurrent, and so i.e. the ones that they did without waiting for the previous results to load. And we also tracked how they engaged with the snapshots, like navigating to a specific one or scrolling through the snapshots. We found that the participants all made concurrent interactions, and like we've seen in the previous pilot, and they all engaged with the snapshots. We observed that when the participants had a specific question, like comparing the geo distribution of different causes of wildfires, they would click through the causes of fires and then revisit each snapshot after they've loaded. So as a result of this usage pattern, a participant explicitly commented that the snapshots made the wait less painful. Another interesting use of the snapshot is as a memory aid. So when the users were summarizing their findings towards the end, many browsed through the snapshots. One commented that the history tool allowed me to go back to my previous thoughts easily and made it easy for me to reference observations. And so participants also pointed us towards possible future work, asking for more capabilities to edit snapshots, such as delete the ones they found irrelevant, which also led us to consider further augmenting the history with richer representations, such as a tree-based structure with the branching factors for their interactions. And so that's a quick tour of interaction snapshots. Thank you for listening, and I'm happy to take questions now.
Thank you for the wonderful talk, Yifan. So we have time for a few quick questions. So please post them to YouTube or Discord. And meanwhile, I'm just going to go ahead and ask my question. So I was actually curious about kind of a low-level aspect of the study.
I'm Wenchao from the
I was
Hong Kong
curious,
University of Science
were
and
there
Technology.
actual latency issues based on like the size of the data, or were you simulating that during the study?
We were simulating the latency. It was randomly sampled between, I think, 5 to 7 seconds, which is on the long end. I don't think people usually would like to subject their users to that latency, but it does happen in the wild.
And do you, I guess, at a higher level, do you think that the magnitude of that latency would affect people's preferences?
In terms of whether they would like to have the latency or not, or?
No, in terms of whether they would prefer the snapshots, depending on, if there's high latency versus like fairly low latency.
Yeah, I guess we did not test on the condition against no latency. My hunch is that the motivation for the snapshots would be vastly reduced. Although it is interesting to ask the question more along the lines of literate computing. So having like a paper trail of your past interactions immediately accessible might raise interesting questions in that domain, but that was not the target of study.
Okay, interesting. Yeah, so we have a question from BC Kwan. He asks, I wonder what are the differences in strategies people take with versus without snapshots?
Yeah, I think some of the participants commented that they had to think a little bit about what kind of questions they wanted to ask, and then they sort of strategize using the snapshots. And so, for instance, like they can ask, oh, how do the causes affect like the distribution of the fires? So if you look at like lightning versus campfire, etc. And so I think that was a more explicit translation of their question to the interaction steps beforehand, as opposed to just clicking on things as they go. So that's one thing we observed. But we could definitely do more to like get a more rigorous understanding of exactly how they would do differently. But we did not do that. As you can see, the sample size was quite small as well.
Yeah, very cool. Okay. Yeah, thank you, Yifan. So there is still ongoing discussion in the Discord chat. So if you have a minute, maybe pop over and maybe interact with some of the folks who are asking other questions.
That's good.
So our next speaker is going to be Wenchao, presenting on improving engagement of animated visualization with visual foreshadowing.
Hi, I'm Wenchao from the Hong Kong University of Science and Technology. This project was done in collaboration with Microsoft Research Asia, and it's about improving engagement of animated visualization with visual foreshadowing. In recent years, animated visualization has been widely adopted to show changes in time series data. A well-known example is Hans Rosling's Gapminder presentation, using the animated bubble chart to reveal the financial and physical well-being changes of different countries over 200 years. However, without additional guidance from a presenter, general audience might feel difficult to pay attention to key information and reluctant to consume an entire animation. People are not sure where to focus when multiple changes simultaneously occur. Informed by the role of foreshadowing that builds the expectation in film and literature, we introduce visual foreshadowing to improve the engagement of animated visualization. In this study, we formulate and apply visual foreshadowing on animated bar charts. We define visual foreshadowing from three perspectives, namely visual effects, time, and duration. Visual foreshadowing can have one or multiple visual effects. The visual effects can be a textual statement or the ones that are attached to specific visual elements. Under the framework, different visual cues can be easily introduced to extend the foreshadowing effects. Given the visual effects, timing is used to specify when the visual effects start, while duration is to control the time length. Specifically, we demonstrate 4 examples of visual foreshadowing that can be categorized into 2 major types: explicit and implicit. Explicit foreshadowing openly suggests the outcome, while implicit foreshadowing leaves the subtle clues by hinting the relevant items. We will use the top global brands ranking dataset to illustrate our designs in details. Prologue is an explicit foreshadowing example. This foreshadowing design is to insert additional text description to suggest the forthcoming events. After noticing the caption about Coca-Cola, the audience focus is guided to see how the related bar animates to meet the description. Pre-scene is another explicit foreshadowing example. The goal of the design is to arouse the viewer's interest to see how the selected bar would change to the final state. The explicit foreshadowing design builds the expectation visually, where the final ranking and the length of the bar are directly visualized. Contour is an implicit foreshadowing example. The visual effect is drawing a contour around the target bar to attract the audience's attention before important change occurs. As shown in the animation, the bar of Coca-Cola with contour is suggesting something interesting will happen. The emphasis is another implicit foreshadowing example. Similar to the contour effect, interesting items will be highlighted before key events occur. As shown in the animation, the visual effect is implemented by decreasing the transparency of those irrelevant bars. To learn the efficacy of engagement enhancement of our approach, we implement a proof-of-concept system that generates animated bar charts with the proposed visual foreshadowing techniques. The prototyping system consists of a foreshadowing configuration panel, a basic animation setting widget, an animation preview panel, a timeline panel, and a data loading panel. Compared to the traditional video editing tools, the user can easily select the specific items in the canvas or from the item list. Then, the user needs to specify visual foreshadowing by selecting the effects and choosing the time range. All the foreshadowing effects with time range will be indicated in the timeline widget. Now the user can preview the synthesized animated visualization with additional visual foreshadowing effects. The user can also remove the unwanted effects by clicking the name of the item in the timeline widget. To understand if our visual foreshadowing techniques could enhance the engagement of animated visualization, we conducted a user study to compare the effects of playing the ranking animated visualization with and without visual foreshadowing. We recruited 12 participants, including 5 males and 7 females that aged from 20 to 27 for this study. The participants were mostly graduate and undergraduate students in a local university with different majors. We used 2 different ranking change visualizations of global top brands with 2 different time periods, and provided the participants with 2 visual foreshadowing settings for comparison. Different types of visual foreshadowing designs are covered under the condition with foreshadowing. Then, we ask each participant to complete a survey about the overall user engagement of the animated visualization. The survey consisted of 12 subjective questions referenced from the previous study. Finally, the user study ended with a semi-structured interview for collecting feedback from each participant. Each participant took approximately 20 minutes to complete the whole study, including the informal interview. The table shows the results of 3 categories of engagement measures. Overall, the animated visualization with visual foreshadowing achieves higher subjective rating than the one without, indicating the effectiveness of our visual foreshadowing design on engagement improvement. In the interview section, we also found that the participants enjoy the visual foreshadowing techniques we provided in the prototype system. To conclude, we introduce visual foreshadowing and propose 4 examples that can be categorized into explicit and implicit types. We see visual foreshadowing as a new form of animation effect that appears before the critical events during the playback of animated visualization to set the viewer's expectations. To demonstrate our approach, we build a proof of concept authoring tool that supports the easy creation of visual foreshadowing effects for specific items. Our system facilitates adding, previewing, and editing visual foreshadowing for the selected items with different temporal ranking data. And our user study results suggest that the proposed visual foreshadowing techniques are useful to engage the audience of animated visualization. For future work, more visual effects and even dynamic visual cues can be introduced and combined with the temporal aspect of our visual foreshadowing. Moreover, other forms of animated visualizations can be adopted. For example, the foreshadowing techniques of direct text description and indirect item indication can be applied to animated line chart or animated scatter plots without too much modification. In the current study, we evaluated general engagement improvement of visual foreshadowing. Further investigation is required to examine the most effective design and setting. Finally, I would like to thank the anonymous reviewers for their suggestions and our funding agencies. And thank you for listening. I'm happy to take any questions.
Thank you for the interesting presentation, Wenchao. So again, we have some time for questions. There's already several rolling in on Discord, so definitely you'll need to visit that afterward to catch up on all of them. But Lynn asks, Cueing and visual foreshadowing are heavily used in film and video creation. There are many techniques that have been heavily studied. Did you take clues from these?
Yeah, yeah. But actually, we just use the for design for the concept illustration. So we indeed do some survey about the visual cues and uh, try to use as much as possible to. But in the paper, it's not
Hi.
the exhaustive design, but we want to use it for as a illustration.
Yeah, great. So John also asks, he says, great work. Does this proof of concept tool, and as an extension, your approach for foreshadowing support the ability to dwell or pause before a foreshadowing progresses? I'd be curious to see how much pacing designs alter your results in the evaluation.
Oh, that's a good question. And I think that would be a very nice future work, nice direction for the future work. We didn't consider the pacing or any timing strategy in the current foreshadowing strategy, but I think it would be interesting to explore in the future.
Okay, great. Yeah, thank you, Wenchao. That was a great presentation. So again, yeah, please head over to Discord. It seems like you've got several other comments and questions maybe you can address over there.
Okay.
So our next speaker is going to be Rupayan, presenting on the topic representing real-time multi-user collaboration in visualizations.
Hi, my name is Rupayan Neogy, and I'm excited to share our work with you on representing real-time multi-user collaboration in visualizations. Now that's a mouthful, so before we dive too deep, let's talk a little bit about the research space of collaborative visualization. In their 2011 paper, Isenberg and others defined collaborative visualization as the shared use of computer-supported, possibly interactive, visual representations of data by more than one person with the common goal of contribution to joint information processing activities. Now this is a nice definition because it's broad enough for various interpretations of what joint information processing activities may be. Previous work in this relatively young field of research has varied in techniques and designs, from real-time visualization synchronization to social spaces for visual collaboration and critique. Now each style has its benefits. The former allows for real-time collaboration and common synchronized views of the data, while the latter affords different users to conduct different explorations of the data, asynchronously contributing to the joint processing of the information. We aim to generalize from these prior approaches by introducing a design space for representing remote users in synchronized visualizations while supporting divergent exploration. Through our review of the literature and past work, we arrived at some core but simple design values to guide our research, the first one being our focus on divergent exploration. We hypothesize that independent exploration of data can contribute significantly to the collaborative experience without synchronizing all views of the visualization. At the same time, we focus on providing shared awareness of users and establishing common ground, two main tenets of collaborative visualization. We also hope to have a minimal impact on the core visualization experience and make versatile designs for all kinds of visualization types and interaction techniques. We present cursors as the basic unit of user representation in collaborative visualizations. These color-coded marks take inspiration from popular collaborative tools and address all of our design values. They have minimal impact, so the core experience is maintained, allowing for divergent exploration. They're versatile. They maintain some level of shared awareness, and they establish common ground through cursor interactions, which we'll explore in a bit. But first, we have to realize that a single cursor design cannot apply to the broad spectrum of visualization designs and interaction techniques. By necessity, these cursors can vary significantly in appearance based on the visualization. So we explore designs across two orthogonal dimensions, situatedness and specificity. We arrive at these dimensions after conducting previous work and performing a design exploration. By varying both the placement of the cursors around a visualization and the amount of specific information we encode into these cursors, we're able to easily create designs suitable for almost any visualization type and interaction technique. For example, in situ generic representations of remote user interactions are effective at establishing common ground across various user states without overcrowding a visualization. Custom cursors provide a more specific way of conveying information within the visualization about remote user interactions. For example, the stock index chart on the left provides color-coded rules indicating the mouse position of remote users without rescaling the entire chart. The figure on the right provides rectangular windows representing the brush selections of remote users on this overview and detail chart. Sometimes a visualization is too data dense, and the in situ cursors will be confusing. So we present the cursor legend, an external generic option for representing users. While these may lose the benefit of encoding information about the location of the remote interaction, they avoid the risk of overcrowding the visualization. In addition, some interaction techniques, such as the panning and zooming on the left and the query widgets on the right, aren't really conducive to placing cursors on the visualization anyways, since it's unclear where we'd place the marks to represent the interaction. Finally, thumbnail legends provide an external but specific way of communicating remote interaction states. These small, high-level previews strip away all extraneous information while encoding the important interaction data that is visible at a glance. We find that these dimensions of situatedness and specificity allow us to create cursor designs for all kinds of visualizations and interaction techniques, as you can see here. But of course, our work is more than just designs. We also present interaction techniques to reconcile the various user states across the collaborative visualization. We introduce peeking, which allows users to temporarily look at another user's view by hovering over a cursor. You can see that these cursors also update in real time with remote user interactions, providing a shared awareness across all users without compromising on any individual experience. Tracking is the obvious next step, as users click on cursors to fully synchronize their view to that of another user. Finally, we also present forking, the idea that a user can follow another user's exploration of the data until they choose to separate, seamlessly breaking out of tracking and resuming their independent exploration. We present this terminology with the foresight of imagining collaborative interaction histories, where we may wish to identify each step in a collaborative discovery in a visualization. So, how did we go about making actually such a system? Well, first, we built it around Vega Lite, a high-level declarative specification of interactive visualizations. By targeting this grammar, we guaranteed that our techniques, if successful, would be very versatile. Our proof of concept implementation converts any valid Vega Lite specification into an online, synchronized experience. With minimal client or server knowledge required, any user can create a Vega Lite specification, add a few lines of code, and have a collaborative visualization running on a server. The system builds off of our design space exploration, providing smart defaults of in situ generic cursors, as you can see on the left, but allowing for customization across all dimensions of situated specificity to allow for custom cursors, as you can see on the right. The system is pretty confusing. So how exactly does it work? Well, real quick, the client listens to user interactions in Vega Lite and translates them into data that is passed through a server to generate annotation cursors on other peers. Our collaborative interaction techniques, such as peeking, work through a simple relay system, passing the entire visualization state from one user to another to synchronize views in real time. There's still much more to do in this space. First and foremost, we would like to move forward with a proper evaluation of our implementation and design space. In addition, as foreshadowed by our discussion on peeking, tracking, and forking, we'd like to explore how collaborative interaction histories can be a visual collaboration tool in themselves. Finally, we'd like to explore how peeking, forking, and tracking might be expanded to allow for more complicated collaboration interaction techniques. That's all the time I have today. You can learn more about our research at the MIT Visualization Group website. Thank you very much for listening.
Thanks for a great presentation, Rupayan. So we have time for some questions. There's already a few on Discord. So Petra asks, she says, first, very nice ideas in here. What if where one person's cursor is in part of the data that's filtered out for someone else?
Yeah, absolutely. So there are a lot of different options that we provided because we realized there's lots of different interaction states that might exist. In the case where someone's interacting with data that's filtered out on another view, then perhaps those
Hello,
X
everyone.
into
I'm
generic
Junxiu
cursors or external specific cursors, such as the cursor legend or the small previews, those might be useful because then even if their cursor might not be visible on your data, it'll be visible in a small representation of that external to the visualization that you're using.
Yeah, thanks. So it looks like there's also the typical comment, not a question, but maybe you can, if you have thoughts on it, you can share. So Matthew says, it would be interesting to see if preferences for these strategies can change with or without accompanying voice or video chat among collaborators. You have any thoughts on that?
Yeah, I mean, obviously, this is only like a relatively minimal level of collaboration in a visualization. If we wanted to add more amount of communication through voice or video chat, that would probably unlock a lot more kind of use cases. I think that what we're aiming for here is that level of minimalness. Obviously, we could synchronize people's cursors, like actual mouse cursors in real time, and then have people have control over other visualizations. And in those cases, maybe it's time to start having active voice calls or video calls along with that. But I think it just depends on the use case. And we tried to be as broad as possible in this one.
Yeah, great. Thank you again. That was a great presentation.
Thank you.
Yeah, so our next speaker is Junxiu, presenting on narrative transitions in data videos.
Hello, everyone. I'm Junxiu from Zhejiang University. Today, I'm pleased to present our work, Narrative Transitions in Data Videos. So, what are narrative transitions? Let's see an example.
Matrix teachers help cut study time and stress, giving students more time to enjoy other things in life. Best of all, they have a proven record of achieving exceptional results, with 82% of students achieving an ATAR above 90.
In the first video clip, a little boy kicks away a football, which is then transformed into the start point of the line and grows along with the line chart. The animation on the football establishes a transition from the non-VIS content to the VIS content. In the second video clip, with the camera zooming into the circle at the end of the line, the circle is transformed into a pie chart that shows the percentage of high-score students. The transformation of the circle establishes a transition which connects the line chart and the pie chart, thereby indicating that the later pie chart is showing the distribution of the end year on the line chart. These transitions in data videos are very interesting. Transition is a type of visual narrative tactic and the attention cue to keep viewers oriented when states change in data videos. It can cement story pieces and visualizations together. However, previous work mainly focused on transitions only between visualization contents, but doesn't cover other designs. Our work aims to investigate the transitions in data videos and provide a comprehensive taxonomy. Here, we consider each video clip is containing two narrative states and one transition between them. A narrative state is defined as an informatically distinct scene for presenting data facts or other video narrative. The narrative state can be an animated content without visualizations or data-driven arguments, or a visualization content that includes standard charts, pictographs, and other data-driven arguments. The narrative transition is the change of two narrative states in a clip. There could be 4 kinds of clips. We only focus on the clips that have at least one state with visualization content. We have collected 284 data videos from reputable sources, such as the leading media outlets and video sites, and we got 3909 video clips that meet our requirements. We mainly consider the following questions when analyzing the transition designs. What are the narrative states? What are changed and what are unchanged within a transition? How transitions visually presented? What's the narrative relationship of the narrative states in a transition? After iterative explorations, we finally summarize a taxonomy and conduct the quantitative analysis. The taxonomy includes the 5 identified transition types. Each type consists of several specific designs. Note that multiple designs can be combined together to establish a transition in a clip. Let me introduce them in specific. First, refresh means a complete update of the previous state. In this type of transitions, no connection exists between the last frame of the previous state and the first frame of the coming state. Usually, this mechanism can be used to present a new topic or an abrupt turn. Halftime as a new short scene between video contexts. Such a scene is comparable to a quick halftime of the staged curtain between the previous state and the coming state. As for camera motion, it updates the state due to the changing viewpoints or screen focus. It is usually used together with other transitions to build the sense of space. And the preserving guide reuses elements in the previous state as a visual guide that directs to the coming state, such as the red elements in the figures. This kind of transitions preserves the same appearance and at the same time guide viewers' attention to a new state by the preserving content. The last one is narrative agent. It means substitutes for data during data-driven storytelling. The transitioned elements could be regarded as agents of data attributes or data values. These transitions are like staged animations of statistical charts. They act according to the change of data. Among these 5 kinds of transitions, preserving guide and narrative agent need craft animations to conduct fluent narrative. They are usually used in data videos to preserve data attributes or encoding data-driven insights, which present narrative information of the visualization content. Within these 2 transitions, changed and unchanged visual variables both exist. According to our investigation, we summarize these visual variables in this table. Each column is a tab of transition, and each row is a tab of visual variables. The blue symbol represents changed, while the empty table item means unchanged. In some conditions, the changed and unchanged designs both exist. Those changed variables consist of the animation of transitions, while unchanged ones preserve the narrative information to maintain congruence of the previous states and coming states. Here shows a case for introducing how transitions help build narrative. To find more details, please read our paper. To conclude our work, first, we investigated a dataset of data videos and clips. Then, we conduct a content analysis based on this data. Finally, we propose a taxonomy of narrative transitions in data videos. As for the future work, first, evaluations are needed to assess the effectiveness of specific transition designs on the engagement and the memorability of data videos. Second, we need more analysis on the data to further explore the relationship between transitions and the narrative sequences. We also hope that the taxonomy can inspire transition designs in other narrative visualizations, such like animated long-form web articles or data GIFs. Finally, we would like to thank our reviewers for their constructive comments and the following agencies for their generous support. We provide a website where you can access the source data and animated illustrations of the taxonomy. That's all my presentation. Thanks for listening.
Great talk, Junxiu. Yeah, I can imagine this taxonomy will be really useful to organize a lot of ongoing work. So while we're waiting for questions on Discord, I have just a quick clarifying one, I guess. You showed a table toward the end of your talk and talked about changed transitions, unchanged, and both. And I was curious if you can give an example of both. That part I missed. It just wasn't clear to me.
Oh, the both doesn't mean it appears in the same transition. It means
Hello everyone.
there
My
may
name is
be many kinds of transitions that belongs to one category, and some kinds the variables of some kinds will change and sometimes will not change.
Okay, I see. That makes sense.
There will be more examples in our website, and I will complete them.
Yeah, actually, maybe you could post a link to the website in the Discord channel. That might. Oh, it looks like somebody's already beat us to it anyway. But yeah, so maybe head over there and see if, as other questions roll in, we can keep interacting with folks there. Yeah, so thanks again, Junxiu.
Thank you.
And it's my pleasure to introduce our next speaker. Alaul is presenting on visualizing information on watch faces, a survey with smartwatch users.
Hello everyone. My name is Alaul Islam. I'm presenting our VIS 2020 short paper on visualizing information on watch faces, a survey with smartwatch users. Smartwatches can access a variety of data, and the first screen people see when looking at the smartwatch is often meant to expose this data. For example, the watch faces on the right show step counts, weather information, watch battery level, among others. However, while the design possibilities for smartwatch faces are almost infinite, we know very little about, firstly, which data types people see in practice, and secondly, which representations are used for which data. Having answers to these two research questions will allow us to learn about opportunities for research and visualization design for smartwatches. We conducted an online search for more than 500 watch face designs in order to find the common patterns of data types and representation forms. We found that common data types can be grouped into three categories. First, health fitness data such as heart rate or step counts. Second, weather planetary data such as weather info, moon phase, temperature, etc. And finally, device location related data such as watch or phone battery level or location name. We also grouped representation types we saw into 5 categories. They are only text, only icon, icon plus text, only graph, and graph plus text. Combining data types with representation categories, we were interested to learn which type of data people consume and how they are visualized. Then we conducted the online survey with smartwatch wearers to investigate our research questions. In the online questionnaire, we asked participants to tell us the data and representation types they found on their watch faces. We provided the list of data types we observed from our online search as well as empty text fields that allowed participants to add data types that were not on our list. After conducting the survey online for 1 month, we received 237 valid responses for our analysis. First of all, we count the number of data types on the watch faces reported by participants. found that on average participants saw 5 different types of data on their watch faces. Next, we were interested in which data types people see on their watch faces. On the left figure, we see that the green health fitness related data was the most commonly reported data items on people's watch faces, followed by weather and device related data. To know more about which types of data are commonly shown together, we performed a co-occurrence analysis. The graph on the right shows pairs of data types that at least 25% of our respondents had on their watch faces. Here, circle color corresponds to the data type category. For example, watch battery level was often shown together with both weather info and temperature. We found that most of the data types can be seen together. Interestingly, distance travel only appears with step count and not with other types of data. Next, we looked at the most common data representation types. Icon plus text was the most common representation type used to display on average 2 kinds of data types on each watch face, followed by only text and only icon. Surprisingly, we found that representations with charts and graphs were the most rare. This should be the opportunity for the future research on smartwatches. We extended our questionnaire analysis by looking at technical details for the 54 models of 20 smartwatch brands our participants reported. We wanted to see discrepancies between which data could technically be shown and which participants actually did see. The graph shows the difference between the number of data seen from our online search compared to the data seen by participants. The wider the gap, the more difference. For example, humidity or wind related data was available to almost all devices but rarely shown in the data reported by participants. This findings raises the question of the visibility of the most unseen charts from the survey. From our survey, we see several opportunities for visualization. First, space for displaying data is very limited on smartwatches. Microvisualizations that combine multiple common data types can help to use space efficiently. Second, we found that the charts and graphs were rare. Future studies need to determine if the wider adoption of visualizations is a question of preference, task, a lack of exposure, and if it requires us to rethink visual encodings for smartwatches. Thank you for listening.
Thanks for the great talk, Alaul. So we have time for a couple of questions. So while we're waiting for folks to post those in the Discord channel, I had a quick clarifying question once again on this paper. So I was curious, like, was the survey that you conducted just based on like the default watch face, or through any potential apps that people might also have on their smartwatches, or just sort of their, like, I guess home screen is maybe, I'm not sure if that's what you call it on a watch, but.
Yes, you're right. We are just conducting that survey just for home screen, just when you just first turn on, you reveal what you see. Okay, so we particularly told, sorry.
Oh, sorry. I was trying to ask if you feel like the home screen is pretty representative of the landscape for data viz on smartwatches.
Well, because it was an exploratory our survey, so we actually first focused on what they see and how those data represented, and we at the beginning asked like what's their display shape, like either it's like rectangular or circular.
Yeah, great. So there's a question from Marty that did you consider audio interfaces in conjunction with graphics on smartwatches?
No, we didn't we didn't ask particularly about those audio designs, what she asked. So we just only focused on data which can represent numerical or categorical data, which represents information or content information. And we told participants avoid like icons, music icons, or settings icons. We didn't focus on our questionnaire.
Okay, cool. Yeah, thank you. Thank you, Alaul. There are a couple of other comments for you on the Discord channel, just skimming through. So if you want to head over there, you can maybe answer some questions there as well.
Yeah, thank you.
So our next speaker is Joao, presenting on evaluating animated transitions between contiguous visualizations for streaming big data.
Welcome to the presentation of our paper Evaluating Animated Transitions Between Contiguous Visualizations for Streaming Big Data. My name is João Moreira and I am from INESC de Lisboa and Instituto Superior Técnico. When there is big data streaming, visualizations must be created with techniques that avoid cluttering, otherwise people will find it difficult to understand the information conveyed. Recently, graceful degradation was proposed as a solution to avoid plotting all data points in the same visual idioms. Its key idea is that different visualizations, positioned side by side, are used to aggregate all data points at different time periods, thus conveying information of current data, recent data, and old data. However, graceful degradation has yet to be used with transitions between contiguous visualizations, which is important so people can understand how data goes from one visual idiom to another. There are some common animation techniques that allow data to be changed between visual idioms. However, they all struggle to handle large flows of dynamic data. One exception appeared with Uran, who explored visualizations using a dynamic flow of information via streaming. However, his visualizations and transitions lacked information regarding data history, which led to additional loss of information context. To address the challenge of providing a continuous flow of data between contiguous visualizations, we propose a set of transitions between pairs of visualizations. This set is composed of multiple alternatives to create a single and uninterrupted view that joins multiple visualizations organized side by side. These visualization techniques represent data that has been aggregated with statistical measures. Each transition starts from a scatter plot, which always represents raw data, and it ends with one out of 5 visual idioms: heatmap, line chart, stream graph, bar chart, and heatmap accumulator. And before moving on, let me just address these two visual idioms. The stream graph was used to represent multiple box plots over time, joining the values from each box plot and creating colored areas representing the maximum and minimum values per time interval and its median and interquartile range. The heatmap accumulator is a heatmap with one variable relating value intervals with its frequency. For all pairs of visual idioms, we propose two basic transitions, the no animation and the fade-in fade-out. We will just exemplify these transitions with the heatmap, the one you are seeing right now. To the heatmap, we propose 3 transitions: the agglomeration in squares, data columns, and grainy transition. For the line chart, we propose 2 transitions, the bottleneck and the points contraction. To the stream graph, we propose the narrowing and the stamping. To the bar chart, we proposed 2 transitions, the pilot lines and the points consumption. Finally, for the heatmap accumulator, we proposed 3 transitions, the point forwarding, the electrocardiogram, and the dilation. To validate all proposed transitions, we created a user study with 28 participants where they were asked to answer a set of questions for each transition technique after watching a video with the transition. Our data was generated and the questionnaire involved 7 questions. Our goal was to compare all different transitions regarding each question. The first 4 were multiple choice questions, each with 1 right answer. The last 3 questions had Likert scale answers. Particularly in question 4, every choice was a statistical measure, for example the mean. Between the scatterplot and the heat map, there was not a single transition technique that stood out. However, the fade and grainy transitions were not significantly worse in any aspect than any other technique, which may suggest they should be chosen over the others. Between the scatterplot and the line chart, no transition showed significant differences in any question. Between the scatterplot and the stream graph, once again, there was not a single transition technique that stood out. However, the stamping had a significant better classification at question 7, which was please rank each transition from worst to best. Between the scatterplot and the bar chart, once again, there was not a single transition that stood out. Our results showed that participants preferred the lines transition according to question 7. However, at identification of trends, the consumption technique proved to be better than the other techniques. Between the scatterplot and the heat map accumulator, as with between the scatterplot and the stream graph, there was one transition technique that stood out as preferable by the participants according to question 7. In this case, it was the forwarding transition. Overall, results suggest that the lack of a transition or a simple fade are not the best approaches, and that approaches designed to illustrate the transformation of data are more appealing and can help understand data aggregations that are being performed. Indeed, participants agreed that the use of animated transitions allows for a better understanding of the evolution of the data flow. Therefore, we recommend these visual idioms. For the line chart, we recommend the bottleneck and points contraction because they are preferable over simple fades and no animations. For the heat map, we recommend the grainy transition because it was not worse than any other transition and because it is preferable to leave out simple fades. For the stream graph, we recommend the stamping transition because it stood out in question 7. For the bar chart, we recommend the pilot lines transition because it stood out in question 7. Finally, for the heat map accumulator, we recommend the point forwarding transition because it stood out in question 7 and it was the best overall performer. Regarding our study limitations, some participants reported difficulties in interpreting the statistical measures represented in some visualizations. There were also cases where the visualization technique was not previously known, namely the stream graph, where participants found it hard to interpret the statistical measures. Furthermore, some participants found it more difficult to follow the data from modules where there is a relationship with time to others with visualizations where there is no temporal context, such as the bar chart and the heat map accumulator. As future work, it is relevant to study transitions between visualizations that do so on different levels. Also, it would also be interesting to automatically detect changes and/or bizarre events in the data flow and highlight them to further ease the analysis of the information being received. Thank you for watching.
Thank you for a great talk, Joao. So it seems like these results can be really informative for choosing aggregation techniques. So I see a few questions already on the Discord channel. So Wenbo says, this looks pretty cool. Will you provide a tool for creating those animations?
Not yet, since this is still work in progress. Yeah, it would. My video went out, but it would be nice if we could actually get. At this point, we're still wondering, as the future work, how to detect bizarre events on when the data changes, because the main idea is the graceful degradation, is how we can change, have several periods of time, and how can different periods be encoded using different visual idioms. Then there's the part when the transition enters.
Hi everyone.
And
it's
still too early to create a tool that could automatically do this, but it would be a nice goal to have a tool that, depending on the data, it chooses a transition to encode a different idiom. Yeah.
And I'm sure lots of people would be very excited to use that if you end up doing that. So there's another question from Robert asking how applicable may the findings be not just for streaming data, but for incrementally loading data?
We do not know it yet. We are still just focusing at streaming data, and also our data was generated by us. We had like a tool that could generate the data that changed the coordinate, for example, which could create data that was incrementing the trend, the overall trend. We could create data that creates the data around the single verb point, but always trying to simulate the big data, the streaming big data, at least for now.
Awesome. There's also a question from, sorry, I lost my place. There's too many comments coming in.
I'll go there after.
Yeah, so there's a question from Lynn. You alluded to this at the end of your talk, but might you allow steering around what features should be prioritized and how would users assess them?
Sorry, I couldn't understand the question.
Lynn says that you alluded to this in the end of your talk, but might you allow steering around what features should be prioritized and how would users assess them?
I'm trying to understand that.
Yeah, perhaps that's something that maybe to hop over.
Yeah, it's better. Yeah, I can answer that after. Yeah, it's better.
There's also several other questions waiting for you.
Okay, thank you. Yeah.
Thank you again for a great talk. Yeah, so it's my pleasure to introduce our final speaker. Sebastian is going to be presenting on gaze-driven links for magazine-style narrative visualizations.
Hi everyone. This talk is about gaze-driven adaptive links for magazine-style narrative visualization, and this is research done at the University of British Columbia. So MSNV, which is short for magazine-style narrative visualization, are widely used to tell stories with data in real-world documents, and I shall just here a few examples from the Times. And this type of document includes text and visualization. And one of the challenges when reading this kind of MSNVs is that the need to map the text to the visualization. So here on this example, I highlighted two sentences in the MSNV text, in red, one in red, one in pink, that refers to specific data points, specific subset of data points in the chart. And so doing this mapping from the text to the chart is known to be a challenging visual task for some users. And this can in particular increase reading time and decrease comprehension. So one of the approaches to tackle this problem that has been studied in previous research is to provide visual guidance to do this mapping. So one example of guidance is the one that we tested in our own previous work, and I will call it gaze-driven highlights. And the goal is to use eye tracking to highlight specific data points in the visualization. And the moving red dot on this video are the user gaze, and you can see on the very right side of the chart where the yellow arrow points that the bar are getting highlighted as the user reads through. Another time. Here you go. And so this mechanism was found to improve the user comprehension of the MSNV, but this was true only for some users, those with lower visualization literacy. And the other users did not have any improvement in comprehension and also reported issues with going back, especially from the visualization to the text. Another form of guidance are links provided upfront in MSNV that connect specific keywords to the described data points in the visualization. And this was found to improve visual search tasks, but in a simple search task where the user were asked just to find keywords. And there was issue with scaling because all of the links were provided upfront in the documents. So our goal here is to combine both approaches and design gaze-driven links, as I will describe now. So the goal is again to use the same eye tracking mechanism as in our previous work to detect what fixation the user, what sentence a user is reading, and provide visual links to connect this sentence to the described data points in the visualization, as I will show on the video. And to avoid drawing too many links, we merge nearby links using branching trees. So here's an example of links, and as the user keeps reading the text, more links can be triggered. We fine-tuned this mechanism in a pilot study, and then we conducted a user study to evaluate the usefulness of the link. So we had 3 groups in this analysis. The first one, group A, is a control group, and this is user who received no guidance at all, and they were recruited in the study in 2018. Then the second group, the group B, is our group, the group from our previous guest-driven highlight work in 2019. And finally, for this paper, we recruited a new group to test the link. All of these users in all of the groups received the same task, procedure, and were recruited among the same population using the same advertisement strategy. And the user had to read through 14 MSNV snippets extracted from real-world documents and provided in a randomized order. And all of these snippets has varying complexity in terms of length and number of data points in the visualization. And then we collected performance data to compare the 3 groups. So for the dependent measures, for each MSNV, we collected accuracy on a set of comprehension questions asked to the user after reading each MSNV, and also reading time. And after reading all of the MSNV, we collected subjective measures about the usability of the links. And because visualization literacy was found to be important in our previous work in the B group, the highlighting groups, we also collect for the link group vis literacy again. So here are some of the results we found. First, we found a significant main effect of group on comprehension and a significant interaction effect of group with vis literacy on comprehension again. So this is shown on this chart, where the y-axis is the comprehension measured in terms of accuracy on the comprehension question, and the x-axis is the vis literacy of the users from low to high. So what we found is that the link group in green had significantly higher accuracy on the comprehension question than the control group in yellow. And this is showing that overall the link is successful, the link intervention is successful in improving the comprehension of MSNVs. We also found that both the link and highlight intervention in green and blue in the chart are the most useful for low vis literacy users on the left part of the chart as compared to the control group. And this is interesting because those low literacy users are also known to be the ones who have the most difficulty reading MSNV. So either type of eye tracking intervention, whether it's the bar highlight or the link, are very useful for these users. And finally, for the high literacy users on the right side of the chart, the link group are the one that obtained the highest comprehension accuracy on the comprehension question as compared to the other groups. And this is again interesting because this was one of the main drawbacks with the highlight group in blue, that we see there is a huge drop in accuracy for the high literacy with the blue line. And this is not the case anymore with the green line, the link group. We also looked at the role of MSNV complexity, but we essentially found no interaction effect of complexity on either comprehension or reading task. So this is interesting because this shows that the improvement in comprehension that we just found for the link group as compared to the control group is consistent regardless of the complexity of the MSNV from easy to hard. And the reading time remains exactly the same, again, compared between the link and the control group. So this is encouraging because it shows that essentially the result we found can scale to more complicated MSNVs. And finally, when we collected the user perception of the link using both usability questionnaire and interviews, and in particular when asked about specific usability items, we found that user provided positive feedback in terms of the usefulness, ease of use, and whether or not the links are confusing. And some of the feedback in particular provided by the user is that the link intervention helps them integrating the different modalities, text and visualization, and was so intuitive to use. And the only negative item was for distraction. So participants reported that the links can be a little bit distracted. Also, it was not a very strong distraction. And the main reason they provided that they sometimes pull their attention away from the text at the wrong timing. So as future work, one avenue of future work is obviously to reduce the level of distraction using, for instance, different ideas are using mixed initiative approach so that the users still are in control of when they want the links to be displayed. Also, we can adapt the delivery of the links to the reading speed of the user so that they are triggered at a better timing. And finally, we could also just provide training to the users, because in these studies, the user receives no training at all on using the links, and that could also, if they know what to expect, this could also reduce their distraction. And finally, we also want to test the link intervention with other types of MSNV and different visualizations.
Yeah, thank you, Sebastian. So again, we have time for a few quick questions. So please post them on the Discord channel. There's a question from Yifan so far, who asks, would the same technique work for mouse hovering or highlight instead of eye gaze, which is a more expensive and less accessible signal to capture?
Yeah, so it's a good question. Actually, another team has done some research on mouse. So far, what they found is that using the mouse does not improve comprehension and can increase reading time. So like one reason to go for implicit activation with gaze is that, the user don't have to think about it and they don't have to learn how to use the mouse. And so that's the reason for implicit interaction. Now, there could be also, what we try to say in the paper is that there could be also some mixed initiative approach where you can use implicit gaze interaction to suggest some possible things to highlight, and then let the user in control of using the mouse to actually highlight things. But in general, for the mouse, so far the results are not conclusive, and it's probably more research to find, to fine tune using hovering with the mouse.
Yeah, there's also a related question / comment from Alex saying it might be nice to have a time slider to revisit past states or transitions. Oh, sorry, this looks like it might be related to previous paper comment. Sorry. There's another one for you though, definitely. That's asking what happens when you pull your gaze away from the text to look at the visualization. Does the highlight disappear?
No, the highlight stays on. Basically, the highlight is detected by your reading behavior on the text. So we capture, we infer what you're reading and highlight things accordingly. So when you look at the chart, we maintain the highlighting.
Yeah, cool, very cool. So yeah, if you want to head over to Discord, it looks like there's some other comments flurrying in. So yeah, thank you again for a wonderful talk.
Thank you.
Yeah, and everyone, please just join me in a virtual round of applause for all of our wonderful speakers today. We're so glad to hear about all of the inspiring work that's happening in interaction and animation. I also want to take a minute to thank our wonderful student volunteer and technician, Jen and Gabriella. Yeah, and the Discord channel will remain open for those who want to keep the discussion going. Yeah, so with that, I hope that everyone has a great rest of their Biz Week.
We present 3 external labeling concepts that allow a user to browse through point sets without the need of zooming in and out. In the first method, labels are distributed on multiple pages. The next method arranges the labels in a single row that can be continuously slid along the bottom side of the map. In our third method, labels are distributed on stacks, which a user can independently browse through.
In our work, we look at how narratives and gamification can be used to foster development of visualization literacy skills in young children between 11 to 13. We present our own instance of such a game, evaluate it in a between-subject study, and report results. We also detail key design considerations for future visualization-based games and highlight many opportunities for future work.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
We propose V2V, a comprehensive pipeline for variable selection and translation for multivariate time-varying data. Our approach contains feature learning, translation graph construction, and variable selection. To demonstrate the effectiveness of our approach, we compare histogram matching, pixel to pixel, and cyclogram to evaluate variable translation. In addition, we also compare an information-aware framework to evaluate variable selection.
Hi, my name is Sarah. In my talk, I'm going to be presenting a visualization to display an overview of multiple sequences of events and attributes. The key feature of our visualization is how easy it makes spotting trends and patterns in the data. You can find more info in the links on the right. Thank you.
How to know if a graph is correctly drawn? Are all the aesthetic properties preserved? To answer these questions, we currently use quantitative methods that require graph structure and are computationally expensive. We propose a new method to directly compute these metrics from graph layout images using convolutional neural networks. Below are the results. To know more about our approach, please attend our talk.
What is insight? It is a question that has bothered visualization researchers for a long time. We're wondering whether visualization practitioners think about data insights in the same way as visualization researchers do. So we interviewed 23 visualization practitioners to understand how they think. To find out more about what we found and the implications to the visualization community, take a look at our paper.
The make of continuous color maps. We present the CCC tool, a new web tool for the creation, editing and analyzing of application-specific color maps. For the precise definition of color maps, we developed a new color map specification. This new structure increases the editability by reducing the numbers of colors to a minimum.
MeetQueues is an interactive visual platform which augments existing tools for meetings with features that help people engage and reflect. Its visualization shows if more people are satisfied or uncertain about the contents of a meeting. Attendees can add comments and upvote others' comments. Attendees can reflect on the contents and what happened during the meeting using the summary page sent after it is over.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
Political debates are a rare opportunity for voters to learn valuable information about candidates and their stances on important issues, but they can also be inaccessible for casual, non-expert users. Through a 2-year design study in collaboration with political scientists and journalists, we created a novel task analysis for exploring transcripts as a casual user and developed DebateViz, an interactive tool for visualizing political debates for casual, non-expert users.
We study viscous and gravitational finger-like features in a carbon dioxide storage simulation applied for global warming mitigation in earth science. To support spatial exploration, we extract rich fossils to guide the finger detection. For temporal exploration, we visualize fingers using glyphs and create a tracking graph to identify temporal events.
A short overview of the presentation for a simple pipeline for coherent grid maps. In a grid map, we transform an input map to a tile arrangement. However, current approaches do not perform well on complex maps such as the Netherlands. We propose a pipeline that generates high quality and coherent grid maps even for complex data using a simple pipeline.
This paper explores the efficacy of using narratives as a medium of explaining the causality in causal networks. Now, towards this end, we provide you a glimpse of CauseWorks, a causality visualization system for generating narratives given a set of interventions and objectives for a causal model. And we further validate CauseWorks through interviews with experts. Please read our paper to know more. Thank you.
We propose a method palettailor that fully automates the coloring process of categorical data and produces discriminable results. Based on both color and data spaces, our method incorporates 3 scoring functions into a customized simulated annealing algorithm. We apply our method to different types of visualizations and compare it with the state-of-the-art palettes through a controlled user study.
Hi, everyone. It is a work about graph visualization. With one node link diagram, dragging node can change the layout of the diagram as you like. But how about more diagrams? Dragging nodes can be laborious. Please come to our talk about exemplar-based layout fine-tuning for node link diagrams. We will give you our ideas. Hi, everyone. It is a work about graph visualization. With one node link diagram, dragging node can change the layout of the diagram as you like. But how about more diagrams? Dragging nodes can be laborious. Please come to our talk about exemplar-based layout fine-tuning for node link diagrams. We will give you our ideas.
This study presents a method to explore hierarchical data by improving RODVIS, one of the visualization techniques for multidimensional data. The user can set options for nodes and check the data in groups or individually in the RODVIS. 3 subviews at the right enable the hierarchical clustering structures of selected data and allow the user to grasp the features of selected data. As a result, this system allows more detailed insight into the data while solving the node overlapping problem.
The blood vessel structure on the human placenta can be an important indicator in the detection of birth complications, but the segmentation of the vasculature tree remains a challenging problem. In our work, we show how MRI visualizations in immersive virtual reality can help medical practitioners to identify blood vessels without the need for a contrast agent. We present the results of a user study and lessons we learned for vasculature exploration in VR.
Chiroplast maps are popular. However, we have better encodings for numeric values. Check out the prism map. Worry about occlusion and perspective distortion? Let's go immersive. Want to have both of them? We present tilt map, a novel interaction technique for transitioning from a chiroplast map to a prism map to a bar chart to overcome the limitations of each. Believe me, tilt map opens up many research possibilities.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
To uncover football tactics, we create spaces and times. We use time query, construct spaces, construct times. Our approach was used for reconstructing team tactics in different classes of game situation. Our domain experts are happy, and the Germans shall win again and again.
MetroSets is an online platform for visualizing sets as metro maps. In this style of drawing, sets are represented with metro lines, while the elements they contain are represented as stations. MetroSets is implemented using a modular 4-step pipeline, with a variety of choices for each step. The final visualization is interactive, with support for all common set operations. Metro Sets is fully implemented and can be found at the displayed URL.
The recent technological advancements in mixed reality extend our ability to evaluate new visualizations faster than ever before. In a user study with 60 participants, we compared 4 situated visualizations using 5 different empirical methods. In contrast to prior work, our results showed no dependency between the user's feedback and the empirical methods.
Atmospheric convection is one of the most important phenomena in meteorology. It is responsible for cloud formation and storms. Yet, the measurements of the convective processes are expensive and scarce. In IsoTrotter, we collaborate with a domain expert to build an empirical model of the atmospheric convection based on paragliding data. We design a novel visual parameter space analysis technique using isostructures in the parameter space to explain and validate the model.
Capturing analytic provenance is important for refining sense-making analysis. However, understanding this provenance can be difficult in distributed collaborations. We present a novel concept, crowd auditing, as a way to help debug distributed sense-making. We implemented the concept in a system called CrowdTrace that visualizes and traces the analysis provenance and elicit feedback to improve the analysis.
We present responsive matrix cells, a focus on context approach for exploring and editing multivariate graphs. For a matrix visualization encoding both adjacency and node similarity, we propose to embed responsive visualizations in these cells. These visualizations can not only detail the aggregated value of a single cell, but also represent multivariate or structural aspects for a group of cells and even allow for editing values.
Urban motion, illustrating the movement of population from billions of sparse trajectory records. Chang'an Avenue correlates with movement flow, the regions with the largest flow volume. Zoom into the region. The southern Huilongguan region is mostly in blue, cut by G6, which could account for its commuting issue. Rainstorm in Beijing, movement speed is much higher on average. At the remote regions of Beijing, there are few local movements.
As word clouds grow bigger and words get pushed into the periphery, viewers are less able to accurately compare data, font size for example, associated with each word. This indicates that large distances between words detract from a reader's ability to extract data from the word cloud, but that this bias goes away with the longer periods of reader perusal, suggesting perusal time being an important consideration for design.
Typically, black hole visualization takes a lot of compute time, but we achieve a quite faithful reproduction at interactive rates on a standard computer. For this, we make use of a novel adaptive grid approach to focus calculations where needed. Coupled with filtering and interpolation methods, we can obtain high-quality imagery. Our approach accepts star catalogs and environment maps and generates the resulting deformations in real time.
This work presents a detailed account of an attempt to explain tightly coupled relationships through storytelling and animation in a multi-user, informal learning environment to a public with varying prior knowledge on the domain and identifies lessons for future design. It offers qualitative empirical findings with particular emphasis on how, despite careful design, visitors may walk away with little knowledge about the data and the problem.
When building the hierarchy for big data, different users may require different hierarchies to meet their diverse needs. However, existing one-size-fits-all methods often fail to meet the diverse needs. To tackle this issue, we present an interactive steering method to visually supervise the constrained hierarchical clustering by utilizing both public knowledge from knowledge base and private knowledge from users.
Generating a stacking ensemble of models is usually a complicated trial and error process. In order to deliver the best and most diverse stacks to the user, we propose StackzenVis, a visual analytics system that supports an iterative process. With different algorithms and quality metrics, instance and feature selection, model optimization, and more.
Over hundreds of tools exist for visualizing genomics data, leaving the analysts with a large design space to analyze before finalizing the visualization. We present a data and task-based recommendation system. The recommendation system uses a sequential model to suggest appropriate visualizations to users. To learn more about our recommendation methodology and results, please visit our poster.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought. Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
University directories routinely become outdated and often lack the information necessary for understanding a researcher's interests and past work. To assist in the exploration of research talent, we have designed PeopleMap, an interactive tool that maps out researchers using NLP techniques. By using PeopleMap, users can explore the diversity of research at an institution and identify potential research talents.
We present Uplift, a system that supports casual collaborative visual analytics in the domain of smart grid technologies. We applied a co-design approach to design, implement, and evaluate Uplift with experts in energy systems and members of the Monash microgrid project. Uplift uses embedded data visualization to show energy data for each campus building.
Hi, please come see our talk if you are curious about how to encode your data so that it can be efficiently queried later at different fidelity levels by fetching only the relevant bits from the disk. The talk is titled Efficient and Flexible Hierarchical Data Layouts for a Unified Encoding of Scalar Field Precision and Resolution.
We present an investigation into design judgment in data viz practice. Our findings show how different types of judgments influence design decision-making. Our findings also show that judgments occur in complex and layered ways while designers move through their process. We discuss implications for future research and pedagogy.
Visual data analysis of large amounts of data demanded a solution which provides users the means to enter into the dialogue with the information visualization. To understand how multimodal interaction using touch, speech, and mid-air hand gestures can tackle this gap, we conducted an explorative interaction elicitation study. We argue that users are highly receptive to use multimodal interaction for visual data analysis and that especially the combination of touch and speech would be promising due to their complementary nature.
Determining the veracity of a factual claim made by public figures has become a common task for journalists. However, fact-checkers face critical challenges as they try to sweep through a long transcript to verify claims. We present ClaimVis, a visual analytics system that supports the journalists to identify and verify claims from a transcript.
We propose a localized approach to topological simplification called LTS, which computes the exact same result as the current state-of-the-art simplification procedure implemented in the topology toolkit. But LTS is an order of magnitude faster as it utilizes shared memory parallelism and constrains computationally expensive procedures onto small subsets of the domain. This approach significantly accelerates an essential part of topological data analysis pipelines.
Table cartograms are a recent form of data visualization that embed tabular data in a grid of quadrilaterals, like a heat map that has been areaed rather than colored. There are lots of different valid outputs for a single input table. Unfortunately, algorithms found in prior work prevent exploration of this design space. We present a web-ready algorithm for creating table cartograms using an optimization-based approach that supports a wide variety of outputs and aesthetics. Find out more at this address or come by our poster.
In this study, we designed PathVisual to fully analyze the pathing dynamics. Users can hover on a pattern diagram to see all the pathing patterns, its characteristics, and how these patterns distributed over phases. They can further click on a pattern to see its phases, select one phase to see the pathing, and inspect the prior statistics during pathing.
Approximately 100,000 cases of head and neck cancer are diagnosed in the US annually. Patients are increasingly likely to survive but often experience acute and long-term side effects. Hence, great importance has been placed on improving patients' quality of life and reducing symptom burden during treatment. Using novel visual encodings, we introduce an interactive system which enables clinicians to assess medical data, providing context for new patients based on clinical features and symptom evolution over time.
With cluttered or noisy line charts, analysis tasks become difficult, for example selecting the most significant peaks in this data. To overcome this, we can turn to data smoothing. However, many methods are available, and while their results look similar, each preserves different properties of the data. We present a framework for measuring the effectiveness of smoothing techniques on 8 different low-level tasks, and our findings summarize the effectiveness of 12 different smoothing techniques.
How do people really make use of space to spatially organize their ideas? To answer that, we collected 280 images from the web, which came up by searching keywords such as brainstorming. And we found spatial organization patterns and interesting observations about how people make use of space.
Do charts provide us with some kind of story? Or is it a message or some kind of insight? A lot of ambiguity involved here, right? We fix this by characterizing the visualization decoding process by providing a fact evidence framework to align the complexity of cognitive tasks and understand the chart interpretability process.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
Functional safety analysis is an automotive systems engineering technique that helps minimize unreasonable risks associated with automotive electronic and electrical systems. We developed a visual analysis tool, Safety Lens, to assist domain experts to perform exploratory analysis of a single project as well as comparative analysis among multiple projects.
Data GIFs are enjoying increasing popularity on social media as a format for data-driven storytelling with visualization. Simple visual messages are embedded in the short animations and are played in automatic repetition. Here we present a structured design space and a set of design instructions to create effective data GIFs.
Hey everyone, I'm Junxiu Zhao, PhD candidate at Purdue University, computer graphics major, and presenting our recent research outcome, Phoenix Map, an abstract approach to visualize 2D spatial distributions. Due to the conflicts between the limitation of display area and the large amount of comparative distributions need to visualize, the current methods are always restricted.